With today's video, we're going to spend some time looking at the gas detector details page. That is the second page on the gas detector assessment, if you chose to include it when you were printing your report. I strongly recommend that anytime you output an assessment report, you include this page because it's probably the most important and the most information-rich page in the assessment report, maybe even more so than the results pages themselves. What this detector details page is going to give you is it's going to give you the tag name or the tag number for each detector. It's going to give you the type of detector. Both the tech, it's going to tell you whether this is an open path detector or a point gas detector. And if you programmed in the make and model of the detector in the program, you're going to see the make and model of the detector right here. In this case, I have just programmed these in as generic open path and generic point detectors. Unlike with flammable gas detector types, their makes and models don't really change the quality of the results as long as you are making sure that you respect manufacturer recommendations on not going too far on the beam length or the path length on an open path detector. You're going to get the XYZ coordinates for the detectors. Like with flame detection, you are going to get the absolute X and Y coordinate of the detector, and like with flame detection, you are going to get the Z coordinate expressed in ALD or above local DEC, assuming you programmed in a non-Z coordinate for the DEC elevation. If you didn't program in the Z coordinate as being something, if you didn't tell the computer what the Z coordinate of the DEC was, then you're just going to get the absolute Z coordinate of the detector. You'll also notice that unlike with flame, we have two sets of columns for gas detection. The DET, this is the detector placement or the transmitter placement if it's an open path. If it's a point detector, you just get the location of the point detector. If it's an open path detector, you're going to get the location of the transmitter, and then over here you're going to get the location of the receiver on the other end of the beam. Like with flame detection, we have detector contributions breakdowns. With individual, this is the percentage of the graded volume that this detector can see or can provide coverage to on the low voted level. And this is the percentage of the area that this detector can see on the high voted level. And you're generally going to see the high be lower than the low, because usually what you're going to have is you're going to have different cloud sizes or different cloud diameters set for the different voting requirements for the dense and dilute cloud. On the voted scheme, we again now, instead of having 3 columns, 1 out of N, 2 out of N, and 3 out of N or 2 out of N plus, we're going to see 5 columns for low voted, high voted, 2L, high low, and 2H. We almost always see plants using high-low voting, so this is probably one of the more important voting columns. And a major difference from flame detection in the flame detector details page. This is not what the coverage drops to if this detector goes into fault. What you're seeing here is how much high voted coverage is reduced if this detector goes into fault. So what you're going to see here is that for this detector, if OPGD1 goes into fault, then low voted coverage goes down by 0%. High voted coverage goes down by 4.4%. Low voted coverage goes down by 8. High low voted goes down by 5.4, and high voted goes down by 0.2. And you see on this open path detector, open path 4, if this detector goes into fault, high or low voted coverage goes down by 0.8, high voted goes down by 8.3, low voted goes down by 11.1. Again, this is different from flame because with flame, it tells you what the coverage drops to if that detector goes into fault. With the gas detectors, it's telling you how much it drops. So that's something to be aware of. This is useful sometimes in that not only does it tell you which detectors are giving you the most coverage, particularly comparing open path detectors, but it also tells you if I'm using high-low voted coverage and this detector, this point detector, is only increasing my coverage by 1.3%. Is that a detector that I want to keep, or do I maybe want to get rid of this? So that's a way to look for both detectors that are underperforming, and it's a way to look for opportunities to optimize or rearrange or reconfigure your detector layout, and maybe reduce your detector count if you have a bunch of detectors that are just not doing anything for you.